Students, welcome to s.mathguru classes. So our main discussion is multipliers method of multipliers, Lagrange method of multipliers of partial differential equation of first order. Now we consider some uh, condition how to solve multipliers if partial differential equation given, how to solve this equation by using Lagrange multipliers. Let the auxiliary equation be dx by p, dy by q, dz by r. These are auxiliary equation. We consider L, M, N may be constant. It may be constant or functions of x, y, z. Then we have dx p by p, dy by q, dz by r. If we multiplying dx by L, then denominator also multiplying by L. And this is M, this is N. This is M, N. And adding this. So L dx, M dy, N dz adding, and L p, M q, N r adding. This is a ratio we can multiplying and adding. If we adding numerator, denominator also adding and multiplying by same numbers. We choose the denominator in such a way that this value must be 0. L, M, N are chosen in such a way that this denominator LP plus MQ plus NZ equal to 0. If this one 0, then we consider numerator equal to 0. Thus, L dx, M dy, N dz equal to 0. This is the rule or formula. So, we get this. If we integrate this, we get a result. Suppose this result is U equal to C1. Solve this differential equation if the solution is U equal to C1. Suppose U equal to C1. If we solving, integrate this, we get a result. Suppose this result is U equal to C. First part is done. Again we consider another multiplier. Similarly choose another set of multipliers L1, M1, N1. In place of L, M, N, we putting L1, M1, N1. Again we consider we choose L1, M1, N1 in such a way that denominator must be equal to 0. If denominator is 0, then numerator also we consider 0. And after solving, we get, suppose the solution V equal to C2. First multipliers we get U equal to C1 and second multipliers we get V equal to C2. And required solution, therefore required solution is f of u comma v equal to 0. This u and this v comma u comma v equal to 0, this is the required solution. This is our main formula. By using this, we can easily solve all the problems. All the problems are very easy. No one can say this solution is difficult, this problem is difficult. These are very easy and very interesting also. So now let us consider one. Solve mz minus ny del z del x plus nx minus lz del z del y, ly minus mx. This one given. The solution here auxiliary equations are this is dx by mz minus ny dy by nx minus lz dz by ly minus mx. So this is our auxiliary equation. Just dx by this, dy by this, dz by this. So we get these are auxiliary equation. Now we taking multipliers in such a way that denominator must be equal to 0. So using multipliers xyz, we get each fraction equal to, we multiplying, so numerator x, denominator also x. This is y, z, this is x dx by x into mz minus ny plus y dy by y into nx minus lz and z dz by z into ly minus mx. Just we multiplying numerator x, this is y, this is z, and here also x, y, z, and adding. So we multiplying this. Now how could you know this is, we multiplying x, this is y? Because here z and y given, x is absent, so we multiplying by x. Here x and z given, y is absent, so multiplying by y, and y and x given, multiplying by z. Ultimately this result, this is the technique. How to find denominator 0? This is the technique. So x dx, y dy, z dz, this is m xz, n xy, n xy, l yz, l yz, m xz. So we get this. So obviously all of this will be cancelled. M xz, this is cancelled. N xy, this n xy cancel. L yz cancel. So ultimately we get denominator is 0, x dx plus y dy plus z dz. Therefore what we get, denominator 0 means, therefore we consider x dx plus y dy z dz equal to 0. We get this and integrate both sides, x dx, y dy, z dz equal to 0. So if we integrate this, then we get this is x square by 2, y square by 2, z square by 2, this is c1 by 2. Now we consider one constant, this is c1 by 2, and dividing both sides by, multiplying both sides by 2, then we get x square plus y square plus z square equal to c1. We get first equation, first solution we get. Next we consider another multipliers. Another multipliers we consider. Now again we multiplying another multipliers in such a way that denominator must be equal to 0. So if we multiplying here m and n given, l not given, so we multiplying by l. N, l given, m not given, and here l and m given, n not given. So we multiplying, this is l, this is m, this is n, this one. Again using multipliers, using multipliers l, m, n, l and m, we get each fraction so we multiplying, this is l, this is m, this is n, l dx, m dy, n dz by, this is l mz minus ny, m nx minus lz, n ly minus mx, this, and this equal to l dx m dy n dz by lmz lny mnx mlz nly mnx. mnx cancel, lmz cancel, lny cancel. So what we get, denominator is 0. L dx plus m dy plus n dz equal to 0. Therefore, what we get, L dx m dy dy n dz equal to 0. So if we integrate this, then we get L dx, this is m dy n dz equal to 0. So this is L dx m dy n dz equal to 0. So this equal to dx means x, integration dy means y, and this is z equal to c2. So we know this condition, if u equal to c1, v equal to c2, then f of u comma v, this is the required solution. We know this. So this is u c1, this one v we get. So solution will be u comma v equal to 0. Therefore, the required solution is f of x square plus y square plus z square comma lx my nz equal to 0. This is our final answer. Very easy solution, very interesting. Consider another problem. Solve the partial differential equation x into y square plus z into p minus y into x square plus z into q and z into x square minus y square, where p equal to del z del x, q equal to del z del y. Solution: the auxiliary equations are dx by x into y square plus z, dy by minus y into x square plus z, dz by z into x square minus y square. This is our auxiliary equation, because we know if pp qq equal to r, then auxiliary equation dx by capital P, dy by capital Q, dz by r. These are auxiliary equation. This p we write denominator, this q denominator, r denominator. Here p means this one capital P and minus y into this capital Q, and this one r. We write this. So we taking multiplying by multipliers. So we get this using x, y minus 1 as multipliers. We get each fraction equal to We multiplying this one by x dx. This is y dy minus 1 dz. And denominator also multiplying by x. This one x square y² plus z multiplying by y square x² plus z and minus 1, this is 1 into z x² minus y². We get this. Multiplying this one x, this one y and this one 1. So this will be x dx y dy minus dz. This is x² y² x² z x² y² y² z minus x² z plus y² z. If you multiply, we get this. Then x² y² is cancel, y² z also cancel, x² z also cancel. So we get denominator is 0. Denominator 0, then we get x dx y dy minus dz. We get this one. Therefore, we get x dx y dy minus dz equal to 0. Now we integrate both sides. If we integrate integration x dx plus integration y dy integration dz equal to 0. We integrate x dx integration y dy integration dz. If integration x dx means x² by 2, this is y² by 2, this is z, this is c1 by 2. We multiplying both sides by 2, then we get x² plus y² minus 2z equal to c1. We get first solution. First solution we get this one, x² plus y² minus 2z equal to c1. Next we consider multipliers. If we consider 1 by x, 1 by y, 1 by z, then ultimately x, y, z will be cancelled. Using 1 by x, 1 by y, 1 by z as multipliers, we get each fraction equal to, so we consider 1 by x, 1 by z as multipliers. We get each fraction this is 1 by x dx, 1 by y dy, 1 by z dz. This is 1 by x into x y² plus z minus 1 by y into y x² plus z, 1 by z into z x² minus y². So this is 1 by x dx, 1 by y dy, 1 by z dz. X cancel, we get y² plus z, y cancel minus x² minus z, z cancel plus x² minus y². So what we get, y² cancel, x² cancel, z also cancel. We get denominator is 0. 1 by x dx, 1 by y dy, 1 by z dz. Denominator is 0. Therefore, if denominator is 0, therefore we can write 1 by x dx, 1 by y dy, 1 by z dz equal to 0. Now integrating both sides, we get this is 1 by y dy, 1 by z dz equal to 0. Dx by x means log x. This is dy by y means log y. Dz by z means log z equal to, we consider log c2. And in logarithm, if it is plus, we can write multiplication. Log xyz equal to log c2. Therefore, xyz equal to c2. So we get two solutions. One is, this is u equal to c1 and this is v equal to c2. Therefore, the required solution is f of, this is x square plus y square minus 2z comma xyz equal to 0. This is our answer. Because if we know u equal to c1, v equal to c2, then f of u comma v our required solution. So this is the required solution of the given problem. So I hope this solution is clear. If the solution is clear, then please like this video. If you are new in my channel, then please subscribe my channel and click the bell icon. Thank you.